All right, this is a test of the prototype linear actuator electromagnetic stamp mill. This is a working prototype. We're going to take a known amount of gold ore in this configuration, which is 1 inch minus essentially, maybe a ½ inch minus. We're going to take 1 pound of this ore and we're going to process it through the system. Upon completion of the processing of that 1 pound of ore, the test will be complete. This is what we would like the material to look like, which is essentially sand. And this is what we processed yesterday. We didn't process much to achieve this, but this is one particular classification that we're looking for. This is the classification we are looking for, actually. Because of issues with the screen, this is also the second state of classification, which this material will be put through an industrial grinder once it's dried to get it to the desired mesh. But the stamp mill was designed on a lab scale to produce this material. This is what we want. This is 150 minus mesh. Not sure exactly what the mesh size is, but I would say probably 150 mesh is a good guess. And that should work to free up the gold that is locked inside of this ore. We processed this material, and it's not very much, but there was maybe 1 speck of visible gold, and that is a little concerning. But where this ore came from, the mine, we'll call it Jason's ore, okay, from Mount Baker Mine and Metals or Minerals. I keep getting that mixed up. MBMMLLC. Okay, it's their gold mine. And he did say that there wasn't a lot of visible gold, okay, free gold in this ore. But we'll move on from that. But the idea behind the stamp mill is to free up that gold from the ore, and we'll process it through a blue bowl concentrator. And we'll go ahead and get this tared out. And well, if it's going to play ball today, and we're going to measure out 1 pound. This ore is damp, but I wouldn't call it wet. Okay, I thought we would be able to cram the entire pound into this little container, but it doesn't look like we're going to achieve that. Let me get a bigger container. I overestimated the density of this material. But, so 1 pound of this material, we'll call this damp, but not wet. And should be getting close. I do have a LED segment out. So pay attention. 1 pound, 0.06 ounces. We'll call it there. And that will be 1 pound, 0.06 ounces. All right, we're going to begin the test. The plumbing on this is not very good, so in the case if we start flooding, we'll shut down the test. We'll terminate the test. This is our 1 pound of material, and we'll go ahead and get the test started. The reed switches are set too low. do have a pretty sizable leak here. We're seeing good ore separation. We'll try not to overload the mill. Yeah, we're getting really good separation. We're going to do a front flush. I'm seeing very, the small 150 mesh particle size is being produced fairly steady. It's very efficient, actually, more efficient than I suspected. We're going to go ahead and secure. All right, we'll see how much we processed. We got a little bit scattered about. But amazingly, this contraption is fairly efficient. You can see the amount of 150 mesh minus that we produced, if you can see through the water. It's quite a bit. Just to run for 5 minutes, we secured because we were flooding severely. Placement of buckets and some massaging of the plumbing. We knew we had issues with the plumbing, but we'll get things cleaned up, and we're going to actually do a weigh, and see how much ore we processed in that amazing small amount of time. But if you can see that, this is surprisingly efficient for a lab apparatus. Okay, that short amount of time, we processed, 3.4 ounces of gold ore, which, 3 minutes? So, I mean, you can do the math, say an ounce a minute. Okay, full tilt. That's a pound after 16 hours. That's 4 pounds an hour. That close to flat out running. That's a good little lab piece of gear, piece of kit that will produce this. We'll go ahead and just break and post this. Okay, this was a good successful test. We're going to continue this off of camera, and this thing is about as aggravating as it gets. And we'll go ahead and just get this posted. Let's go ahead and see the material that we got out of that short run. I think this is a 100 mesh classifier, and we'll go ahead and get this material poured in and get it classified out. Okay. That should be good. Expect that all will be classified the same size. Okay, there's a small material, and wasn't a lot. But for 2 minutes, I will take it because it is enough with my rudimentary panning skills to actually do a crude pan on that material. And there's a lot of contamination from the paint of the gutter system I'm using. I don't even know what that apparatus is called. A tapered, what is it called? At the end of a sluice that directs the water. Anyways, I want to get this material panned completely down, which it pretty much is now. We'll see if there's any free gold in it. Okay, we panned everything down, which was already pretty much concentrated. One little speck of gold right there. I'm making double dog sure that's not just a piece of pyrite. And because this stuff is extremely hard to pan, and I'm a novice panner. But right there, I highly doubt it's going to show up on the camera, but there is a little speck of gold. Now, I've seen very little free gold in Jason's ore. Very little. Okay, which is the specimens that I've received, got out of his ore has been outstanding so far. I like the pyrite specimens almost as much as I like the gold specimens. Obviously, gold is worth more, but those little pyrite specimens on quartz, you know, they're $5 a piece. You can, so I mean, the ore is quite valuable. Okay, if you're buying it to hunt for specimens, but if you're buying it to pan, you may be disappointed. But one little speck of gold, I still see it, it's right there. And I think that was a success for 2 minutes worth of milling, okay, that we obtained enough material to pan. And there's more of this right here. Our screen method is not the best, but it works. So we're going to, off camera, we're going to process the rest of that 1 pound. I think there was 12.4 ounces left or something like that, 12.6. And we're going to repan this material too, just for the heck of it, because this is difficult to pan because of the pyrite. It really is. So I think it was a successful test.